stuck with just me on this one. Mr. Bobby is, I don't know, like out walking his dogs or something. And so tonight we are going to be talking about, or it's tonight for me, but might not be for you. We're going to be talking about conditional probability. So conditional probability is a probability that makes my brain go. So I have to think really, really hard about it. And sometimes I'm super successful, and sometimes I have to just like keep going back and keep going back and keep going back until I kind of figure it out. Okay. So if you get frustrated in this section, I am there with you. And remember that through struggle comes knowledge. Okay. So let's look. Our conditional probability is a probability that event A will occur given that event B already happened, okay? And the notation for this is the probability of A given, that's the bar, B is the probability of the intersection of those. And if you'll remember from the last section, the intersection of those is when they happen at the same time, right? Like senior boys. So this would be like the probability of senior boys, choosing a senior boy, given that you are talking only about senior boys. Okay, so the multiplication rule, second essential knowledge, I had to pause and come back real quick. The multiplication rule states that the probability that events A and B both will occur is equal to the probability that event A will occur multiplied by the probability that event B will occur, given that A has occurred. This is denoted, the probability of A intersect B could be found by multiplying P of A times P of B given A, okay? Mr. Bobby just texted me and said he is ready to make a video, so I'm gonna let him in, and then I will be back. You won't really know that I'm gone because I'm just gonna pause. Okay, well, I'm patient waiting for Mr. Bobby to hop on, so I'm just gonna keep on teaching. Okay, so here's the problem. We've got this table of seniors and juniors and table of boys and girls, and so we want to find the probability of a boy given that it's a senior. So that's how that's said, a boy given that there's a senior. So it says to find the P of B vertical bar senior, the probability of choosing a boy given that we chose a senior. We look at the chart and see that there are 11 seniors and 8 of them are boys. So 11 seniors, so you can see here, 11 seniors, 8 of them are boys, okay? So the formula looks like probability of boy given senior would be the intersection of boy and senior divided by the probability of senior, which is 8 out of 20, so that's the intersection, divided by the probability that you get a senior, which is 11, 8 out of 11. On the AP exam, you need to either show this formula or this division of probabilities, okay? So if you just do 8 out of 11, you don't get full credit, you only get partial credit. So you need to make sure you do 8 out of 20 divided by 11 out of 20, and then reduce that down to 8 out of 11. Pretty simple. To find senior given boy. So to find the probability of choosing a senior, given that we chose a boy, so we're going to switch them, right? We're going to say, is this commutative? We look at the chart and we see there's 12 boys. We already suspect no because we've changed the denominator, and 8 of them are seniors, right? So the probability of a senior given that it's a boy is the intersection of seniors and boys divided by the boys. So 8 out of 20 divided by 12 out of 20, that's your 8/12 or 2/3. In a multiple choice question, this would be given as 2/3. If you leave it as 8/12, and I highly recommend this, you will get full credit on the AP test. If you give 8/12 and then reduce it wrong, they will deduct points. So don't reduce in an open response question if you don't have to, okay? I'm missing Mr. Bobby. I know this is a little more boring. Consider the following, consider the following table taken from the Practice of Statistics. That's your book. Page 216, about the years of education completed by age. So did not complete high school. You can see here that there were 30,512 people in this that did not complete high school, and then 166,435 total people in this population, okay? So it says if a person is chosen at random from this population, from this 166,435 people, what is the probability that the person is between 25 and 34 years of age? So if I go to 24 or 25 to 34 years of age, there's 400 or 41,000. There's Mr. Bobby. Let's let him in. I don't know if y'all can see me. Mr. Bobby, we are literally in the middle of recording. So we are all saying hi in our.
Hi. I'm here now. What's up? Are you teaching without me?
I am teaching without you. I got impatient because I'm really hungry and I haven't eaten dinner yet. So just letting you know.
Just pause and then.
No, we're not paused right.
I'm just going to join in the middle of the video.
We are not paused.
Oh, so we're like actually in the middle of the video. Literally in the middle of the video, I jump in.
Yeah.
Okay. So I have no idea what you're talking about, so I'll just let you keep talking.
Yeah. So we're looking at a table, and our population is 166,435 people, and we're looking at the comparison of age ranges to years of education, and my dog is really wanting in on this conversation.
Sure. I understand.
And so the first thing we want to know is, what is the probability that a person is between 25 and 34 years of age?
Well, that would be the total. There's no condition. We're talking about conditional probability, right? If I remember.
We are.
All right. So, but we don't have any condition on that. So it's the 41,378 divided by the 166,435, I think.
Yep. Perfect. You're brilliant.
All right. I am.
What is the probability that the person is between 25 and 35 years of age, 34 years of age? I don't know why I can't say that. And 55 and over years of age.
It can't be both of those age bands at the same time, can they?
It can't.
I don't think I can be 34 and 55 at the same time.
You can't. It'd be weird if you could, though.
I mean, that would be pretty cool power. I mean, I don't have that power, but, what do I know?
So remember, guys, that the and means you're looking for the intersection of two things. You don't join things together. Don't add things together with the word and. With the word and, you will look for where they're occurring at the same time. And you cannot be, no matter how many times your mom tells you that it's her 29th birthday, you cannot be two ages at once. You just can't. All right. What is the probability that a person is between 25 and 34 or 55 amp? I don't see what happens when I copy and paste. It's bad. 55 and over years of age is what that's supposed to say. So now we've switched and to or. Can we do that, Mr. Bobby?
Or now we can add this. Yeah, we can add those two columns. And whatever the 41,378 plus 52,22 is. I'm not going to even try to do that in my head.
Wuss. So yeah, we absolutely can add. We can do it a couple ways. We can do what he said, where we add the big numbers together and divide by 166,435, or we can find the probability of each individual one and then divide. And then add. Sorry. So yeah, perfect. What is the probability that a person is between 25 and 35 years? Oh, I said it again. Between 25 and 34 years of age, and that they have completed 1 to 3 years of college. So what's the word here?
Now we're looking at just the column of the 25 to 34. See, I can do it.
I'm proud. I've been struggling with my words all day.
But we're only looking in that first column. So we're only considering those people, and that would be a total of 41,378 or 387. Now you got me doing it. And so we're going to find where the number is for the 1 to 3 years of college. That'd be 11,659. So So we take that 11,000 number, divide it by the 41,000 number, and get something around 0.24 or
You
something.
think so?
I think so.
I
No?
divided by 166,435.
Well, is an and, wait. Oh, well, I thought, wait, they had to be in the first column.
So it's just an and problem. So just the intersection of the two. So if it had said given,
Oh, I thought this was a conditional one.
right.
So,
And guys, this is my point that I made at the very beginning of the video where it's like probability is dumb because if you change one tiny little word, the entire problem changes. Okay. So in this problem, we say, okay, where is this and this occurring at the same time?
yeah, okay, I get it. Yeah, I read yeah,
Yep. And it's so easy to do that. I do that all the time. I do that more than
I
Mr.
just
Bobby
did
does,
it.
if I'm being honest with you.
Yeah.
Okay. So what is the probability that a person is 35 to 54 years of age or has 4 or more college or years of college?
Okay, now we're going to have an overlap because if we take the 35 to 54 people, that would be, I need my iPad. That'd be
he
the
says
second column.
he says he
What?
needs color.
I need color here. Yeah, I need me some color. But we want that second column, the 35 to 54 column.
Should I annotate
And
for you?
you could, you know what, I could probably annotate, yeah, without, I don't need an iPad for a stinking iPad for
I
this.
got you. Look, I'm circling the 35 to
Even
54.
doing it in my color, thank you. And we want these guys right here.
So
All
now
right.
he's circling the
No. We want the column below that. Sorry,
right.
four more. I was reading the problem below it. We want this column or this row. But these guys right here, they're double counted. If we use, I mean, we could use this number and this number, but we're having the double counting here
It
because
was
they're
hard
not
to
used.
see what this number and this number were. So he's saying
Yeah.
we could take the row column, the row total and the column total and add them together, but that means we've added 19,878 twice.
So we have to take him away at least one. I have to take him away once.
Yeah.
So
we're looking at that formula that we talked about the last video where we say, okay, this plus this minus this, or we do this the way that Mr. Bobby likes to do this, and we add all the numbers in the rows and the columns, but we only add the 19,878 once, right? So we add 10, 3, 4, 10, 3, 4, 2 plus 19, blah, 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 plus 8,005 plus this, plus this, plus this. And then
you can add these 6 numbers.
Yeah.
And then divide by the total.
Yeah. So that is another way to do it. Remember, we don't care. It doesn't matter, but you have to show us how you got it. You can't just give an answer without a method. Some of you ran into this issue on the last test and you really, really got smacked around by it because you gave me a single answer with nothing to back it up. Can't give you credit for that. Sorry, loves. We're not full credit anyways. Okay, let me clear off all of our mess here. It says if the person is 55 and over years of age, what is the probability that they completed 1 to 3 years of experience? So this is a given problem,
This
a
is what I was
conditional
thinking
problem.
earlier. So now we're only going to, we know they are 55 or over, so we're only going to consider these ones that I'm doing in pink because that's my color. All right.
I wasn't trying to steal your color. I was trying to make you happy because I was including your color.
Okay. And so we're only considering these. We're not even going to look at the others. I could cross them out, but what I want is the 1 to 3 years. So I want these folks right here, and I'm going to divide by that number right there.
Right. Remember we talked about this, the whatever is after the given is the denominator. So in this case, think about like the condition is the denominator. So the condition is if the person is 55 and over. Yeah. So easy peasy, right?
Okay.
So that's, wow, you're just writing all over the place for absolutely no reason. Just, why are you doing that?
Because I can.
Yeah, and remember, show your work. Um, you either need to show me this or this, AP rules and all that jazz. Okay. Oh no, I didn't. Just pretend like you're not seeing this. Cool. Yay. Okay. If a person is vaccinated properly, the probability of his or her getting a certain disease is 0.05. Without a vaccination, the probability of getting the disease is 0.35. Assume that a third of the population is properly vaccinated. Okay, so now we're going to get some wonky statistics. I would pause right now in this video and reread that and process those words. When I decided on this problem, I actually had to work it twice. That's why I decided on it, because I had to work it twice. Okay, if a person is selected at random from the population, what is the probability of that person getting the disease? What is the probability of that person getting the disease? So the population, so it says if a person is selected at random from the population, what's the population?
That's everybody.
All people. Okay.
But we know that 1/3 of them are properly vaccinated.
Right.
Okay. So this 1/3 goes with this, but I know the rest of the population is 2/3.
Mm-hmm.
Assuming there's 100% of the population or one. So I'm thinking we're taking 1/3 times 0.05 and 2/3 times 0.35.
I'm thinking you're right. And that's going to give us a quarter of the population. So again, that is the probability that a person is going to get sick. Okay. All right. Next question says, if a person gets the disease, it's not funny that they get the disease. I'm laughing at the scribbles that Mr. Bobby made, by the way. If a person,
tried to hide that so they could.
Thank you. If a person gets the disease, what is the probability that he or she was vaccinated? So what is the condition?
That the person gets the disease.
Okay. And so that's our denominator for our problem. Okay. We just figured that out. What is the probability that he or she was vaccinated? So we need the probability that they're vaccinated over the probability that they get the disease.
Where did the point? I don't see where the 0.166. Should that be 0.05? No.
Hold on. I think it's me not being able to type. It's hold on. What
See,
did
I
I do
was doing
here?
a favor. That
See, I picked this problem now. I
I
can't
think
even
that should be
remember.
0. Should that be point? I think that should, because that's the probability that they were vaccinated.
What is the probability that
We
he or she was vaccinated?
because we know that.
Yeah.
Or is that no? That's one.
Third. It's a third. So I think I my that's what I'm saying. I think I can't type.
Okay.
So it should be. I don't even know where 0.0166 came from.
Is it 5 divided point? Is it 0.05 divided by
It is.
1/3?
Look, it's 1/3 of 0.05. Okay,
Yeah.
sorry. How about this? How about I remember now? And I told you at the very beginning of this that I have to think so hard about probability. The probability that he or she was vaccinated and got the disease, right, is got the disease and the part of the population that was vaccinated. So that's the 1/3 times the 0.05, which is
Yeah, that's right.
0.01667. Okay.
That's it. That's right.
Yeah. So I should have done a better job here with what I put in the numerator, and I would have remembered why or where that number came from. So this right here is the probability that we are vaccinated intersecting with the got the disease, okay, which is this part of the population. Does that make more sense?
Mm-hmm.
And then divided by the part of the population that's vaccinated.
Yeah.
Or no, got the disease.
Yeah.
Yeah, so
Yeah.
7%.
Got it. Any all got the disease.
All
All right.
right. How about that?
That'll do. That'll do, pig.
Ability every time. It's like I can't ever
I do
teach
love
this
me
all the
some.
way through without missing one. Okay. Yellowstone National Park surveyed a random sample of 1,526 winter visitors to the park. They asked each person whether he or she owned, rented, or had never used a snowmobile. Residents were also asked whether they belonged to an environmental organization like the Sierra Club. I don't know what the Sierra Club is. The two-way
How
table.
do you not know what the Sierra Club is? Oh
Sorry.
my God.
The two-way table summarizes the survey responses. So we're going to define event E as the environmental club members, S as snowmobile owners, and N as never been used. Never used. Yeah.
Okay.
So we want to find the probability of N given E. N given E. What does that mean in context?
So that would mean we want, given E, we want that column yes, right?
Mm-hmm.
So we want this here column, right? And the no we never used, so that would be these guys right here divided by this guy right here,
Mm-hmm.
I think.
I agree.
Okay. So those are the environmentalists who never used a snowmobile.
Yeah. So there's a lot of ways you could say this, but this is the probability that someone has never used a snowmobile given that they are in the environmental club. And it is 0.695. Good job, Mr. Bobby. You're brilliant. Now I could.
All right.
All right. Suppose we randomly select one of the respondents. Same setup with events. Given that the chosen person is not a snowmobile owner, what's the probability that she or he is an environmental club member? Write your answer as a probability statement using correct symbols for the events.
I think you're gonna try to trick me this time, but these are the owners. That's the complement of the owners, right? So we're given that is not a snowmobile owner, so I got to look at those two columns, right?
Mm-hmm.
And we want the probability that she or he is a member of the environmental club. That would be these guys right here. So I'm going to add them together and get 189 and divide by these two numbers. When I add them, that's going to be like 1,200 something, I think. Did I do it right or did I do it wrong?
You did it. Now I need you, how would we put that in probability statement?
Well,
Using
it
your
would be,
S's and N's.
yeah. So it would be S given S complement. It would be the probability of E given S complement.
You giving us a compliment? Ooh, good job, Mr. Bobby.
Because I could have worked backward or opposite of that and dealt with the homeowners or the
Yeah,
snowmobile owners, but
yeah.
so
I think you did
you
perfect.
did it the right way. You did it the way that I did it, though.
Yeah, yeah. And again, he's right. This is definitely not the only way you could have done this problem. See what he's doing with the circling and the circles inside the circles? This is exactly how I do it too. I'm trying to determine like what's the overall given information and then what specific information within the given do I look at. So that's it. You're going to be working on a Khan Academy assignment, calculating conditional probability. And this right here, this dog is being rude to me because I'm not good at probability. And I also think that sometimes I have bad luck when it comes to thinking.
You did okay.
All right.
I think
Bye,
I
guys.
think we did. Sorry, guys. Sorry I was late. Bye.